A developer just released an AI agent framework that assumes every agent is trying to attack your system. NanoClaw forces every AI agent into isolated containers, treating them as inherently untrustworthy rather than hoping they'll behave. This represents a fundamental shift in AI agent security. While existing tools like OpenClaw run agents directly on your machine with optional sandboxing that's usually disabled, NanoClaw makes isolation mandatory. Every single agent gets locked in its own ephemeral container that's created fresh and destroyed after each use. The timing couldn't be more relevant. Recent surveys show business leaders still don't trust AI agents for real work, according to Fortune's reporting on Harvard Research. Meanwhile, IT Pro found that IT leaders are missing out on huge financial gains because they can't trust current AI agent deployments. NanoClaw's approach is simple but radical. It uses Docker containers on Linux and Apple container technology on macOS to create what the developer calls a zero-trust architecture. Each agent runs as an unprivileged user with access only to explicitly mounted directories. The security model assumes agents could attempt prompt injection attacks, sandbox escapes, or other malicious behaviors. Instead of relying on application-level security checks as the primary defense, NanoClaw uses operating system container boundaries as the main protection layer. Configuration lives in a simple JSON file at config/nanoclaw/mount-allowlist.json. By default, the system blocks access to sensitive paths like sh directories, .newpg files, .abus credentials files, private keys, and other credential stores. Each agent gets completely isolated file systems and separate Claude session histories. This prevents both malicious behavior and cross-agent data leakage. If one agent gets compromised or goes rogue, it can't access other agents' data or your system's sensitive files. The technical implementation creates fresh containers for every invocation. Unlike traditional approaches where agents persist and accumulate access over time, NanoClaw agents start with zero permissions each time they run. They must explicitly request access to specific directories, and those requests are filtered through the allow list. This creates obvious friction compared to existing tools. OpenClaw and similar frameworks prioritize ease of use, allowing agents to run with broad system access by default. NanoClaw forces developers to explicitly think about what each agent actually needs to access. The philosophical divide runs deep. Current AI agent tools operate on what security experts call a trust-based model. They assume agents won't misbehave and rely primarily on application-level checks. NanoClaw flips this assumption, treating every agent as potentially hostile from the start. This mirrors broader trends in enterprise security. Zero-trust networking, where every connection is verified regardless of source, has become standard practice. NanoClaw applies the same principle to AI agents, verifying and limiting every file system access. The performance implications are significant. Creating and destroying containers for each agent invocation adds overhead compared to persistent processes. But the security benefits may justify this cost as AI agents become more capable and widely deployed. Early adoption will likely split along predictable lines. Security-conscious enterprises and developers working with sensitive data will embrace the isolation model. Teams prioritizing rapid development and experimentation may stick with more permissive frameworks. The broader context matters tremendously. As Phone Arena recently noted, many users still can't trust basic AI search results, let alone autonomous agents with system access. NanoClaw acknowledges this reality instead of assuming trust will magically appear. What makes this particularly interesting is the timing. AI agents are rapidly gaining capabilities, from code generation to system administration tasks. The window for establishing secure deployment patterns is closing fast. Once insecure practices become entrenched, changing them becomes exponentially harder. The framework also addresses a subtle but important issue: cross-agent contamination. When multiple agents share the same environment, they can inadvertently access each other's data or influence each other's behavior. NanoClaw's isolation prevents these interactions entirely. Looking ahead, this security-first approach may become the standard as AI agents handle more sensitive tasks. The current trust-based model works fine for experimental or low-stakes applications. But as agents gain access to financial systems, personal data, and critical infrastructure, mandatory isolation starts looking essential rather than optional. The real test will be adoption. Security frameworks often fail not because they're technically inadequate, but because they create too much friction for developers. NanoClaw's success depends on making container isolation feel natural rather than burdensome. For now, we're watching a fundamental choice emerge in AI agent architecture: trust by default with optional security, or security by default with explicit trust grants. The path the industry chooses will shape how safely we can deploy increasingly powerful AI agents in the real world.